Alright, polar coordinates. First thing we're going to discuss is the difference between rectangular coordinates and polar coordinates. First, rectangular coordinates is what we're familiar with. We have the x-coordinate and the y-coordinate. A polar coordinate has what's called a pole. Notice on our XY plane, our pole is located at the origin, and our polar axis goes along the x-axis. This is our polar axis, and it's a ray. Starting point along the polar axis. The pole coincides with the origin. The positive x-axis coincides with the polar axis. Alright, so let's take a look at what this looks like. Keep in mind, your rectangular coordinate is your x and your y. A polar coordinate looks like this. We have r, comma, theta. Now, if r is greater than 0, okay, r is equal to the distance a point is from the pole. How far? That's the distance point is from the pole. Okay. Theta equals the angle. Could be in degrees or in radians. Okay, now this angle is formed by the polar axis and the ray from the pole through the point. Let's look at an example. So here's an example. We have a distance of 2 units and an angle of pi over 4. So we would first, here's our pole, here's our polar axis, and here is our ray with the point on it. Notice the angle from the polar axis to the ray is pi over 4. And the units, 1, 2 units. That's our distance to the point. So this point here is found by the distance from the pole, comma, the angle from the polar axis. Now, this is when r is greater than 0. Let's take a look at an example when r is less than 0. Okay, so we have r is -3. Our angle is 2 pi over 3. So notice from the polar axis we went 2 pi over 3 radians, and then if we go 1, 2, 3 units, that would be positive 3. But since it's negative, we move the opposite direction. 1, 2, 3. Okay, so if r is less than 0, we move the angle and extend the ray in the opposite direction. So instead of positive 3, we move -3, and there's our point. Okay, let's look at 4 examples. Why don't you pause the video and try to draw these 4. Okay, I'll reveal one at a time. So, for example 1, well, it's going to be kind of hard to do, but we'll try. So for example 1, it should look like this. So notice we went 5 pi over 3 radians, and then we went out 1, 2, 3 units. So this polar coordinate represents this point. Okay, example 2. Okay, notice we went negative pi over 4 radians, and then we went out 1, 2 radians. Okay, example 3. Now our angle is 0. Now that's going to be 0 radians. So we're on the polar axis. 3 units from the pole. 1, 2, 3. Alright, finally, example 4. Here we go. Pi over 4 radians. And since it's negative, we go the opposite direction. 1, 2. And that is our point for example 4. Okay, so what we want to do now is we want to find several polar coordinates of a single point. So we have this polar coordinate, 2 pi over 4. So first of all, let me show you how to draw this. Here's our pole. Here's our polar axis. Okay. Now pi over 4 is positive, so we're going to go counterclockwise. Pi over 4. It's going to be approximately, somewhere in here. Pi over 4. Now to go 2 units, we're just going to make a couple slashes here. And we're going to go ahead and go 1, 2. So we're going to call that. So that's our point, 2 pi over 4. Now, to get another coordinate for this point, we would add how many radians in a full circle? 2 pi. So to get another point, we're going to do 2, comma, and we're going to do pi over 4 plus 1 full circle. So 2 pi over 4 plus 2 pi. Root over 1, common denominator, and we get pi plus 8 pi, 9 pi over 4. So 9 pi over 4. Okay. Now we can also get this point if we go, say, pi units and then go backwards. So let's take pi over 4, add pi, common denominator, so we get pi plus 4 pi is 5 pi over 4. Let's see, let's take a look at this. So pi over 4 plus pi gives us 5 pi over 4. That puts us pi over 4 plus 5 pi over 4 puts us over here. So that's going to put us over here. And we want to go backwards. So it's going to be negative 2 because we want to go backwards. And 5 pi over 4. So now we found 2 more. Now we've been going counterclockwise, so let's go clockwise now. So let's go ahead and go this direction all the way around the circle. So this time we have to subtract 2 pi. Common denominator. So pi minus 8 pi, and that would be negative 7 pi over 4. So we'd have 2 comma negative 7 pi over 4. So that would be going around. In 2 units. Finally, we could take pi over 4 and subtract pi, and then go backwards. So pi over 4 minus pi, and pi minus 4 pi is negative 3 pi over 4. So we're going to go backwards to negative 2 because we're going to end up over here if we go back pi, and negative 3 pi over 4. Okay, we're going to go ahead and convert polar coordinates to rectangular coordinates. These are the two formulas that you need. These are both derived from, this one is derived from our cosine. Cosine of theta is equal to x over r. Sorry. That's how we get this. And then this one is derived from the sine of theta equals y over r. Little manipulation, and that's how we came up with these two. So very simple. Example 1, we have a polar coordinate of 6, comma, pi over 6. Okay, so we know this is our r value, and this is our angle. And so to find the x coordinate of our rectangular coordinate, we just plug them in. So we're going to have 6. So plugging the 6 in, plugging the pi over 6 in, we got 6 times the cosine of pi over 6. Make sure you're in radians. So that means that our x coordinate is going to be 3. And our y coordinate, plugging the numbers in the angle, y is going to be, oops, I did that wrong, sorry, I wrote down the wrong one. X is going to be 5.2 or 3 radical 3. 5.2. This is the better one here. And the y is going to be equal to 3. Remember that the cosine of pi over 6 from your unit circle is the square root of 3 over 2. And so this would be 6 times the square root of 3 over 2. So that's how we get 3 radical 3. And then this is going to be 6 times the sine of pi over 6 from our unit circle. So 1/2, 6 times a half is 3. So converting, this is polar, and then to rectangular, 3 radical 3, comma 3. Don't know why I put that there. Okay, so now let's take a look at converting the other direction. Example 2. So let's say we have the point 2, negative 2. These are rectangular coordinates, and we want to find the polar coordinates. So for polar, we need r and we need theta. So the first thing we would do is we'd plot the point. So 2 to the right and 2 down. So this is the point we're trying to find. So first thing we need to do is we have a right triangle here, so 2 and negative 2. So to find theta, we know the opposite and the adjacent. So we're going to set up tangent of theta equals negative 2 over 2. So the tangent of theta is equal to negative 1. And we're in the 4th quadrant. And if you look on your unit circle, theta is going to be negative, look at your unit circle, pi over 4, negative pi over 4. So we have just found theta. Now to find the radius, we use the Pythagorean theorem. So 2 squared plus negative 2 squared equals r squared. So we have 4 plus 4 equals r squared, so r is equal to the square root of 8, which simplifies to 2 radical 2, and that would be our radius, or I should say our r value. That's the distance from the pole. Okay, your assignment.